Okay, so let's look at number 8. It says, write the equation of the following graph, and I'm going to write it as a sine function, okay? So what we're going to do is we're going to use the method that we used in class to see the transformations that are occurring with A, B, C, and D. Okay, so there was a certain progression that we used during class to help us in this regard, okay? So first let's start off by identifying that we're going to use a sine function, okay? And from the sine function, we know that the default graph is going to increase. So from the parent function of sine, we know that it's going to increase, and it looks something like this. That's one whole period of sine, okay? So the halfway point, if you will, right here, is going to be our D value. This is the vertical shift that occurred whether it went up or down, okay? And in this one, we can see that our D value is the middle of this wave, which is right here. It moved up from its original y is equal to 0, otherwise x-axis, it moved up by 1. So D is going to be a positive 1, okay? Now we also know that like this is A, or amplitude. And I can see from this wave, either going up by 1 or down by 1, that our amplitude is in fact going to be 1 unit. That's how big the jump was to get from this y equals 1 to y equals 2. Okay? So D and A, D and A are accounted for. Now I need to find B, C. So I need to find B, I need to find C, and I also need to find the period. Okay? Okay, so did the graph shift any to the right or to the left? Well, we know that the parent function for sine does start at like a 0, if you will, and goes up. So there was no shift whatsoever with this. We're going to say that C is 0. So that means we're going to start at an x value of 0. So now C is accounted for. Now we just got to figure out B. And remember, B, since I'm talking about sine, our default period for sine is 2 pi. And it's 2 pi over B is equal to our period. Okay? So our period we're going to get from the actual graph of how long does it take for it to repeat itself. Okay? Notice that it started here at 0 and it went all the way over here to 2 pi. So my oval, if you will, over here is going to be 2 pi. So this whole thing is 2 pi units long. So that's my period. And if I were to highlight that over here on the graph, I would highlight it like the following. From 0 to 2 pi, that's how long this wave recreates itself. That's the period for this wave. Okay? So we're going to put that 2 pi right here, and then we're just going to solve for B. So if I multiply both sides by B to get it out of the denominator there, I would have 2 pi is equal to 2 pi B. And then if I divide both sides by 2 pi to get B all by itself, you see that those 2 pi's cancel out, and I'm left with B is 1. Okay, so B is 1, C is 0, so on and so forth. Okay, so now let's finish this off because we have 2 other ones as far as what is our max and min going to be. Now I know that I'm using something that I already have the picture, but if you can do this process with ones that we're doing transformations with, these graphs are really easy to do if I'm kind of overkilling it, if you will, with this process right here. Okay, so if I have an equilibrium at 1, okay, like y equals 1, this is my D value, and I know the amplitude is 1, that means this will be a maximum of 2. And if I go down 1, I know that this would be 0. So this is how we know on the graph we're going to plot 5 points. 1, 2, 3, 4, 5. My first point, the x value is 0, the y value is 1. That's how I get 0, 1. My point, the x value is 2 pi, and my y value is 1 again. That's how I get 2 pi and 1. And what's in between 0 and 2 pi would be right here in the middle, which is going to be at 1 pi. So my x value being pi, my y value will be 1 as well. And then last but not least, I need to find my midpoints. Between 0 and pi would be pi over 2. Between pi and 2 pi will be 3 pi over 2. So my x value would be pi over 2, my y value would be 2. This is how we get these values. My x value would be 3 pi over 2, my y value would be 1. Whoop, not 1 on that one. It would be 0, because it lines up right here. And that's how I get 3 pi over 2, 0. So what is it that I got from all of this? I got the fact that my amplitude is 1, my b value was 1, my c is 0, and my d is 1. So if I plugged all of these values in this equation up top, I would get f of x is equal to 1 times the sine. So let me just go ahead and write them in here in just a bit. Let me write them up here so you can see it. So a is 1 times the sine, b was 1, parentheses x minus 0, and then it's going to be plus 1. And if I simplify this, this 0 isn't needed, this 1 isn't needed, this 1 isn't needed because they're all understood, so I'm left with sine of x plus 1 simplified, which in this graph is what you see in the red. Okay? So a little overkill again. I just wanted to make sure that you understand the transformation method of how we create this box over here. But yeah, you could just go straight to the wave and say, this is the d value at 1. This is the amplitude of 1. The c value, you would not see a shift left or right from the original sine function because it was going up. That's why c was 0. And then last but not least, the way we found the period was we asked ourselves, how long is this wave from here to here? And it's from 0 to 2 pi, which says 2 pi was our period. We know because it was sine, it came from a default of 2 pi over b, and we solved b for 1.